Okay, with that, we're going to switch it over to Dan Quinn. Dan is a grad student. He's co-advised by Hannah and myself. Dan is in his third season of collecting data. He came out of Michigan State, where he got his undergrad and graduate degrees, and he's been working on a really good project that's funded by the corn growers, looking at how to manage nitrogen when you follow a cover crop. So, Dan?
All right, can you hear me all right? Good. All right, so again, I'm a grad student. I work with Hannah and Chad. I'm in my third and final year, so the light is at the end of the tunnel. But following the completion of my PhD next spring, I'll be heading a little bit north for the folks in Indiana that are here. I recently took a position at Purdue, so I'll be the extension corn agronomist at Purdue starting next fall or next spring. I'll be taking over for Bob Nielsen up there, and so it'll be exciting to move up there and hopefully get to keep working with the folks in Kentucky, and hopefully seeing a lot of you at meetings down the road. So kind of the basis of my projects the last few years, this is just one of 3 projects that I've had, is trying to understand how do we manage corn nitrogen when we have a rye cover crop that's implemented. Transition slides here, there we go. So in Kentucky, kind of when I got here, and kind of the basis of these projects really was that a lot of farmers in Kentucky were really interested in using rye as a cover crop. And a lot of that really centers around, conserving that soil and helping with erosion and helping build the organic matter. No-till was started in Kentucky to really capitalize and try and conserve a lot of the shallow soils that Kentucky has, the erosion issues that Kentucky has. And a lot of farmers kind of want to take that to the next level. And rye produces a lot of biomass and grows about anywhere as a cover crop, and it does a good job of really holding that soil in place and helping build those soil levels. And it also really helps with weeds as well. It can limit a lot of the early season weed populations we see. But a lot of farmers were noticing a lot of issues in their corn crop when it followed rye. And that can be highlighted in these pictures here. So these pictures were taken last year. This is corn planted following rye, and this is corn planted not following rye. These are taken right next to each other in Lexington, same day. I took these pictures right next to each other. The only difference these two plots have is one has a cover crop and one doesn't. But the corn on your left is significantly more yellow. We're seeing quite a bit more nitrogen stress. We also see decreased vegetative growth in that corn when it is following rye. So some of those issues really stem from rye. One, produces a lot of biomass. It uptakes a lot of nitrogen. It uptakes a lot of moisture as well. That biomass has really high levels of carbon. When you have really high levels of carbon in that rye cover crop, a lot of that nitrogen you apply, especially earlier on in the season, can get what they know is known as immobilized. So it's immobilized in the soil, and that corn just can't use it. Also, this high level of biomass can also contribute, if you're putting your nitrogen on that surface, you can actually lose a lot of volatilization as well. So rye can contribute to some nitrogen stress issues with corn that we've seen. So really the basis behind these projects is trying to understand.
Hey, Dan, I just put you on mute for a second. We were getting some odd audio feedback there. I'm going to try to unmute you and we'll start back up. If you want to back up about 15 seconds on your on what you were talking about. So let me get you back on unmute and let's try this again.
really the basis for my project.
Dan, we're still getting some feedback. All right, let's pause for just a moment. Do you have if you've got a headset close by, let's try that out, Dan, and see if that'll pick that up. What we will do is, let me mute that for a moment. While Dan is getting that set up, I think what I'll do is go ahead and get into my presentation, and I'll do a short version of it here until I see Dan get back into the screen. That way he's already back. If he gets that plugged in here pretty quickly, we'll just let him go back into it, and we'll have him back up a slide and get into it that way. Considering the number of folks that are on here, we appreciate you all sticking around. We've actually been working pretty good up to this point. I had a little bit of audio issue, but we're fortunate that most of it's working pretty well. Dan, once you're plugged in and good to go, let's go ahead and give another audio check and see if it's feeding through better. Go ahead and give us a test run, Dan.
You hear me now?
Got you now, yes.
Does it sound better?
Much.
Good.
So go ahead and probably just back up to the start of that slide. I think that's about where the sound cut out. So go ahead and pull that slide set back up, wait about 2 seconds, and then start into it.
All right, does it sound better now?
Yes, much better. Go ahead.
Let's try this again. Okay. So really the kind of what I mentioned before is kind of the basis of my research projects were centered around, okay, we have been seeing some nitrogen stress in our corn when it's following rye, and that can be illustrated by these two pictures here. So corn on your left here is following a rye cover crop. Corn on your right is not following a rye cover crop. These pictures were taken the same day. These plots are side by side, and the only difference between these two plots is that one has rye and one doesn't. So corn on your left, it's got visual nitrogen stress, so it's a lot less green. Corn on your right, we also see decreased vegetative growth in that rye cover crop on the left. So when it comes to using a rye cover crop, rye really produces a lot of biomass, and that's one of the pros of using rye. But when it produces a lot of biomass, you get a lot of carbon in that rye biomass. When you have so much carbon in that rye, a lot of times what we see is we see a lot of nitrogen immobilization. So we apply fertilizer early on in the season. That corn just can't take up that nitrogen due to that high amount of carbon in that rye biomass. So a lot of mobilization. Also, with that heavy rye residue, if you're putting your nitrogen on the surface, you can get a lot more volatilization as well. So we're just seeing different ways, different issues with that rye cover crop, specifically when it comes to limiting the amount of nitrogen that's available to the corn crop. So kind of the basis of my project, this one project we have, is trying to understand, okay, what do we do about this nitrogen issue? Is there ways we can manage our nitrogen specifically so that we can limit the nitrogen stress that we're seeing in the corn crop early on in the season? And do we need to change our management practices? Do we need to change the way we apply our nitrogen so we can limit the nitrogen stress we're seeing? And two, allow farmers to use rye without seeing the yield reductions, the nitrogen stress in corn moving forward. So we had 3 locations. I've done this for 3 years, so I'm in my 3rd year here. We had 3 locations across the state of Kentucky. Lexington, Kentucky, we've done for 3 years. Glendale, Kentucky for 2 years. That's an on-farm location. And then Princeton, Kentucky for 2 years. So Lexington was no-till. We actually irrigated Lexington, and that was following soybean. Glendale, Kentucky, that was no-till, rain-fed following soybean. And lastly, in Princeton, was a no-till rain-fed following corn. So we really tried to encompass, one, a lot of different locations across the state, and two, a lot of different management practices, a lot of different systems across the state, so we can kind of encompass basically management and locations across the whole state and try and encompass this across all of our data that we collect. So we had three main factors that we looked at specifically in these studies. The first is rye cover crop. We used a rustic cereal rye, which is a very common variety of rye that's used for cover crop use. We seeded that with a drill, about 60 pounds per acre. Comparing that versus no rye cover crop. We chemically terminated that with glyphosate. We shot for about 14 days prior to corn planting, but usually with weather and everything, it ended up being around 21 days prior to corn planting. Then second, we looked at nitrogen fertilizer timing. So we had two different timings on exactly how we applied our nitrogen in these studies. So first timing, we used 30 pounds of nitrogen per acre. We applied that in a 2x2 starter through the planter at planting. And then we put the remaining amount of nitrogen at pre-plant. So immediately at planting, we put the rest of our nitrogen on. And then secondly, we looked at a split nitrogen application. So again, we used that 30 pounds of nitrogen per acre. We applied it in a 2x2 starter as well. And the remaining nitrogen was surface banded. We actually waited later in the season, timed around that V6 growth stage. So that'll be referred to as a split when I talk about the next data slides, and then the pre-plant as well. Then we had a total of 6 different nitrogen rates that we looked at in these studies. So all the way from 0 upwards to 270 pounds of nitrogen per acre. So these figures here, what we really want to try and present with these figures is understanding, one, how does the nitrogen timing aspect, so we have across the top here, pre-plant nitrogen and split nitrogen, and the impact of the rye cover crop. So red here is no cover, blue is rye cover, specifically on how corn responds to nitrogen fertilizer. So right here on the y-axis, we have corn yield. So as we move up the y-axis, corn yield's increasing. X-axis, we have nitrogen fertilizer rate. So move left to right, the amount of nitrogen that's applied is increasing. And this is from all 3 locations from the last 2 years. So Glendale here on the left, we have Lexington here in the middle, and then Princeton here on your right. And kind of what the main thing we want to point out to with these figures here is specifically the difference between the 2 timings. So pre-plant N and split N. And specifically in Glendale and Lexington, where we had the highest levels of rye biomass the last couple of years, when I look at pre-plant nitrogen and the difference between no cover and rye cover, across the board, really doesn't matter how much nitrogen I apply, I'm still seeing a yield reduction from that rye cover crop at Glendale when I apply all my nitrogen up front. Same in Lexington as well. We look at the corn response to nitrogen, looking at that difference between no cover, which is the red line, and rye cover, the blue line. I'm still seeing yield reductions when I apply all my nitrogen up front from that rye. So if I apply all my nitrogen up front with a rye cover crop, it really doesn't matter how much nitrogen I'm applying, I'm still seeing a yield reduction from that rye. But we'll switch gears here to that split nitrogen application. And what's kind of interesting, what we've been seeing the last couple of years, is that when I hit a certain level of nitrogen, so this is roughly around 175 pounds of nitrogen per acre, about 150 pounds of nitrogen per acre, these 2 lines begin to converge. So that's that split nitrogen application. So if I apply the amount of nitrogen that's generally recommended in the corn crop that I need, and I apply my nitrogen, we aren't seeing that yield reduction in that corn crop when following a rye cover crop. And that's specifically at Glendale, Lexington. Princeton, we did not have the levels of rye biomass last year. This year's a different story. We have much more rye biomass, so we're hoping to kind of see some of these results again in Princeton. But it's important to note that when I apply my nitrogen and I apply a recommended amount of nitrogen, we're really not seeing a yield reduction from that rye cover crop. So in this last figure, the last graph I presented, we broke it out between all the locations. Now, with a lot of my data the last 2 years, and one we'll add in our third year, is we want to combine everything together. We want to take all the data across all these different systems across the state, bring it all together, and help give farmers, this is a general idea, regardless of what management system, regardless of where I'm at in the state. This is a general idea what will happen between the nitrogen timings and the rye cover crop. So this is across all the studies and all the years. Left is the pre-plant nitrogen, on the right is the split nitrogen. And again, similar to the last figure, we have the red is the no cover and the blue is the rye cover. And this is, again, corn grain yield response. So as we increase on the y-axis, corn yield levels increasing. X-axis, we have nitrogen fertilizer rate. Move left to right, the more nitrogen is being applied. And we're seeing this similar trend that we saw in the last figures with when we combine all the data together. When I apply my nitrogen up front as a pre-plant or an at-plant nitrogen application, regardless of how much nitrogen I apply, I'm seeing a significant reduction in yield when corn is following a rye cover crop. But when I move to a split nitrogen application, so I apply 30 pounds of nitrogen per acre at planting, wait until that V6 application, apply the rest of my nitrogen. At the lower nitrogen rates, we're seeing a little bit of a yield reduction in corn. But when we get up to those higher nitrogen rates, those recommended nitrogen rates in corn, we just aren't seeing the significant yield reduction in the corn crop when it is following rye. So overall, what we've seen in the last couple of years with this project is that the split application of nitrogen fertilizer, so that 2x2 plus V6N, provided more pronounced benefit to corn following a rye cover crop compared to the pre-plant N. So when we step back and look at across the board, a split nitrogen application is, in my opinion, what I've seen is probably the best way to go regardless of whether or not you have a rye cover crop. But you can probably get away with an at-plant or a pre-plant N application without rye. But when I have a rye cover crop in the system, we're just seeing that a split nitrogen application is just better every time when we look at across all the last 2 years and all the data that we have. So implications for farmers, when following a rye cover crop, farmers should look to incorporate a split application of nitrogen fertilizer, both to improve nitrogen use efficiency in their corn and also reduce the nitrogen fertilizer requirements and also reduce that rye or that corn yield loss when it is following a rye cover crop. So with that, I'd like to thank everybody on this slide here, especially the Kentucky Corn Promotion Council. They funded my research the last 3 years. So they allowed me, I see a few folks from Michigan here. So I'm originally from Michigan. So Kentucky Corn Growers allowed me to come down here, have my projects funded, and able to spend the last 3 years here and get my degree and move on. So I really appreciate their help and really appreciate everyone else on this slide as well. So with that, hopefully my audio worked all right. It wouldn't be a virtual field day without some technical difficulties, but I can take any questions if you have them. Or
Dan, you've got one question about whether you looked at early burn down effect on carbon tie-up.
So we didn't look at, I guess, early burn down. We didn't look at on carbon tie up in the corn specifically. Basically, all we did is we took that rye cover crop biomass samples. We looked at the amount of carbon, the amount of nitrogen they have, and then take that ratio and try and estimate maybe whether or not there was some specific tie up. But we haven't looked at early termination. We are looking at really extremely late. We're actually planting green in that cover crop and looking at how that can influence carbon nitrogen ratio and potential tie up as well.
Okay. All right. Thank you. It's a really good question. There's a lot of other dynamics that we really didn't look at. I think Dan has got a really good first cut at some of the challenges we see with the cover crop. I think with the increasing rainfall we've seen the last few winters, the fact we've had some mild winters, it's evident that cover crops are important. There are some fields where we can't just do no-till by itself. We need a cover crop in there to keep those soils in place, particularly when we're coming out of a soybean crop that has lower biomass, lower residue, and doesn't tend to stay in place near as well as what corn does, for example, when you're falling behind a corn crop. So there's a lot of reasons for us to consider cover crops, and that means we need to try to get them into our systems and make them work well with our cash crops also.